Betelgeuse, the enormous red supergiant closest to Earth, has shown a remarkable decline in brightness in recent years, sparking a wide range of reactions worldwide. Some theories suggest this fading might signal the approach of a supernova, a catastrophic explosion that raises concern among scientists and the general public alike. Betelgeuse, a major star in the Orion constellation, has regained some of its former brilliance after dimming, yet it seems to be entering a phase of reduced activity. Experts are now pondering the future of Betelgeuse and whether its eventual detonation could have any impact on Earth. Orion, one of the most iconic constellations in the sky, is well known for its two primary stars, Rigel and Betelgeuse. The latter, also referred to as Alpha Orionis, is the largest and most luminous star in Orion. Observations made by NASA's Hubble Space Telescope and various other observatories revealed that Betelgeuse underwent an extraordinary mass ejection in 2019, an occurrence never recorded in any star of its kind. Although coronal mass ejections, CMEs, are relatively common with our Sun, this particular outburst from Betelgeuse is unique and has generated significant intrigue among astronomers. This massive burst of mass expelled by the star was 400 billion times greater than the typical CME observed in stars like ours, briefly obscuring some of its light and leading to its unusual dimming. Estimates regarding the distance of Betelgeuse from Earth vary, with some placing it as far as 724 light-years away. Measuring the distance to red supergiants such as Betelgeuse is challenging due to their vast distance and unusual traits. Betelgeuse is one of the most luminous stars visible from Earth, shining with about 100,000 times the brightness of our Sun. However, such intense luminosity comes at a cost. Betelgeuse is expending its energy rapidly, burning through its fuel and speeding up its inevitable demise. The star will eventually exhaust its fuel supply, collapsing under its own gravity and potentially triggering a supernova, a violent explosion that might eventually leave behind either a neutron star or a black hole, assuming current scientific theories hold. Does Betelgeuse pose a danger to Earth? If the star were to explode in a supernova, its outburst could have catastrophic consequences for Earth. Supernovae are capable of emitting light so bright that it can rival an entire galaxy, and even if Betelgeuse is relatively distant, such an explosion would be hard to ignore. Since the last supernova observed in our galaxy was in 1604, and the most recent one in 1987 occurred in the Large Magellanic Cloud, 169,000 light-years away, the destructive potential of a nearby supernova remains an intriguing yet concerning possibility. If such an event were to unfold within our galaxy, it could have profound implications for Earth. Supernovae, though spectacular, are much less powerful than gamma-ray bursts, which are on an entirely different scale. While supernovae have the potential to obliterate biospheres and blanket planets in deadly radiation, it is their ability to strip away a planet's ozone layer that is particularly troubling. A weakened or destroyed ozone layer exposes the planet to harmful ultraviolet radiation, which could result in an extinction event. The initial radiation burst from a supernova is dangerous, but the more insidious threat comes in the form of cosmic rays that arrive hundreds of thousands of years later, capable of further damaging the planet's surface and potentially preventing life from recovering. Historical records show evidence of past supernovae. For example, traces of iron-60, a radioactive isotope formed during supernova explosions, have been detected in Earth's oceans and lunar regolith, suggesting that the Earth may have been affected by supernovae within the past few million years. Although astronomers have ruled out any imminent supernova threats, they have discovered another potential risk. Certain types of supernovae emit radiation that can travel vast distances and inflict damage on planets like Earth. When a star nearing the end of its life is surrounded by a substantial amount of material, a specific type of supernova may occur. The shock wave from the initial explosion strikes the surrounding disk, triggering the emission of vast amounts of X-ray radiation. This high-energy radiation has the potential to deplete a planet's ozone layer by as much as 50%, which could induce an extinction event within a range of 150 light-years. Fortunately, no such X-ray supernovae are currently known to be near enough to Earth to pose a direct threat. These findings have caused astronomers to reconsider the boundaries of the galactic habitable zone, the region within galaxies where life is likely to exist. Star formation in the outer regions of a galaxy is too low to create the necessary elements for rocky planets, while the inner regions, where stars are born and die quickly, are equally hazardous due to frequent supernovae irradiating the surrounding areas. This research suggests that the inner boundary of the galactic habitable zone may be farther from the galactic center than previously thought. So, how would Betelgeuse's supernova appear from Earth? While the biosphere on Earth would likely remain intact, the spectacle would certainly be impossible to miss. According to astronomers Goldberg and Bohr, Betelgeuse's explosion would result in a luminosity roughly half that of the full moon, visible for several months. This brightness would be visible even during the daytime and cast shadows during the night. For several years after the explosion, the supernova's remnants would continue to be visible to the naked eye. Although Betelgeuse's supernova would be a fascinating event, it would not be without consequences. The global fascination with such a phenomenon would be undeniable, but the long-term implications for Earth's environment remain uncertain. As scientists continue to monitor this red supergiant, we can only wait and watch, hoping that the threat, if any, is far off. The outcome of Betelgeuse's eventual supernova explosion would be a stunning sight, but not without significant consequences. The enormous burst of light from such an event would likely be the second brightest object in our sky, right after the sun. During its peak, it would shine with an intensity so great that it could easily outshine the moon. This would cause the star to become visible during daylight hours, casting visible shadows in the darkest of nights. The sheer brilliance would captivate observers worldwide. Despite its blinding light, it's important to note that visible light emitted by a supernova accounts for only a small fraction of the total energy produced. The more pressing concern is the high-energy radiation released, typically in the form of gamma rays and X-rays. These forms of radiation are extremely dangerous and have the potential to strip the Earth's ozone layer, a protective shield that prevents harmful ultraviolet rays from reaching the surface. Without this layer, life on Earth would be exposed to dangerous levels of radiation, increasing the risk of a mass extinction event. The aftermath of the explosion would not end with the immediate burst of energy. Cosmic rays, subatomic particles accelerated to nearly the speed of light, would follow, continuing the devastation by bombarding the planet for hundreds of thousands of years. These particles have the power to penetrate Earth's atmosphere, further degrading the ozone layer and potentially altering the course of life on the planet for millions of years. The effects of such an event would be long-lasting, preventing ecosystems from recovering and possibly stalling the reestablishment of life on Earth. While we have not experienced a supernova of this magnitude in our own galaxy for centuries, there is growing evidence that such events have occurred in the past. Traces of iron-60, a radioactive isotope produced in supernovae, have been discovered in sediment layers and lunar soil, hinting that Earth may have been exposed to the fallout from a nearby star explosion within the past few million years. Though no immediate threats from supernovae are predicted, the knowledge of their potential dangers has prompted astronomers to keep a close watch on nearby stars, including Betelgeuse. Researchers have also uncovered another type of supernova that could pose an even greater risk. In some cases, a star's final explosion can be surrounded by a massive disk of gas and dust. When the shockwave from the explosion collides with this material, it generates an intense burst of X-ray radiation, capable of traveling vast distances. This X-ray emission can deplete a planet's ozone layer significantly, increasing the likelihood of a catastrophic extinction event. These types of supernovae, while not yet discovered close to Earth, could pose a serious danger if one were to occur within a few hundred light-years. The realization of this additional threat has caused astronomers to revise their understanding of the habitable zone within our galaxy. Previously, the habitable zone was thought to extend farther from the galactic center, but new evidence suggests that the inner regions, where stars are born and die quickly, may be far more hazardous than previously believed. The frequent supernovae in these areas could irradiate planets in their vicinity, making them inhospitable for life. This has led scientists to propose that the outer boundaries of the galactic habitable zone may extend farther than originally thought. Looking to the future, what would a supernova like Betelgeuse's look like from Earth? While the explosion itself would have little to no impact on Earth's biosphere, the event would still be a spectacular sight. According to researchers Goldberg and Bohr, the supernova would shine with a brightness comparable to half of the moon's, visible for several months. During its peak, it would be so intense that it could be seen during the daytime, casting long shadows even in the dead of night. As the supernova's remnants fade, they would remain visible to the naked eye for several years, making it a truly unforgettable celestial event. While the spectacle of Betelgeuse's explosion would captivate audiences around the world, its long-term effects on Earth remain uncertain. The supernova's radiation would still pose a significant threat to the planet, especially with the potential for the ozone layer to be severely damaged. Although life on Earth may survive the event itself, the consequences of prolonged exposure to harmful radiation could alter the planet's ecosystems, potentially causing significant disruptions to the environment for thousands or even millions of years. In the long term, the potential for a nearby supernova to cause significant harm to Earth remains a matter of ongoing research and concern. While Betelgeuse's imminent explosion may not result in the complete annihilation of Earth's biosphere, the radiation emitted would still present an incredibly powerful and dangerous force. The initial burst of energy from the supernova would likely include a combination of gamma rays and X-rays, which have the ability to deplete the ozone layer that protects life on Earth from the sun's harmful ultraviolet radiation. The absence of this protective shield would leave the planet exposed to dangerous radiation, which could have severe consequences for life, including potential extinction events. Following the supernova's explosion, cosmic rays, highly energetic particles traveling at nearly the speed of light, would arrive in the Earth's vicinity. These rays can pass through the atmosphere and continue their destructive effects for hundreds of thousands of years. While the immediate blast from the supernova might be devastating, it is the long-lasting effects of these cosmic rays that could prove even more damaging. Over time, they would continue to disrupt Earth's environment, preventing the recovery of its ecosystems and potentially causing a prolonged period of instability for life on the planet. Iron-60, the radioactive isotope produced during supernovae, has been detected in Earth's oceans and in lunar soil samples. This discovery suggests that Earth has been exposed to the remnants of a supernova explosion in the not-so-distant past, possibly within the last few million years. Although astronomers currently do not see any supernovae within a threatening distance from Earth, the detection of Iron-60 raises concerns about the potential hazards of a nearby star's explosion. These findings highlight the need to closely monitor the stars that reside within our galaxy, particularly those in the late stages of their life cycles, such as Betelgeuse. In addition to the threat posed by traditional supernovae, astronomers have also identified another potential risk: a specific type of supernova that occurs when a dying star is surrounded by a large disk of gas and dust. When the supernova explosion sends out a shockwave, this shockwave collides with the surrounding disk, producing a tremendous amount of X-ray radiation. This radiation can travel vast distances and has the potential to significantly deplete the ozone layer of any planet within a certain radius. A planet exposed to such radiation could face catastrophic consequences, including the triggering of an extinction event. Fortunately, no stars exhibiting this type of X-ray supernova are known to be located near Earth. However, the discovery of this new type of supernova has caused astronomers to rethink the boundaries of the galactic habitable zone, the region of space where life is most likely to exist. Previously, scientists assumed that the galactic habitable zone extended farther from the center of the galaxy.